let's start the webinar. I think most of us are having exams. They will join us.
Okay. So I'll just start by sharing my screen.
Yeah.
So what I'll do is, so basically I'm going to give you about how to do survey and mapping, all the uses you can use with Mission Planner. So a little bit about me. So I've been doing this since 2010 when I joined the ArduPilot development team. I've been doing it. I had my own job for a fair bit of and was doing it after hours, but currently I work for CubePilot. So they help fund Mission Planner development and other projects which are autopilot related. So it's quite good. So that's about me. So what I'll do is I plan on doing live demonstrations of everything that I plan to show today. So if you have any questions, you can ask me probably towards the end, and yeah, we can go from there. So I'm just going to share my screen. Okay. So now can someone confirm that my screen is working?
Yes, we are able to see your screen.
Yep, okay. So the first thing we're going to do is, I'll just load up my copy of Mission Planner. Okay. So the first thing we got to do is, for all this, everything I'm going to show you today, I'm going to use the simulation tab and SITL. So like for any kind of testing that you want to do to try out different types of missions, or the way the aircraft will respond, whether it be a quad, there's plenty of good ways to test using the simulation. So what we'll do is I'm going to start with a multi-rotor and basically just use that to do all the demonstrations today. So I just start that up now. Okay, so the trick with SITL or loop simulation is that it always uses the current master. So all the features that are available in the newer than the current release of Pilot are available in this SITL instance. So as you can see here, it's starting right in my backyard at the moment. All this information about how high it is, how fast it's going, the ID of the vehicle. So if you had connected to more than one drone, the number of the current HTOP and the current battery level of this virtual drone. So yeah, so what we'll do is we'll get straight into how we would use this for survey and mapping. So let's pretend that you already had the camera set up on the drone. So if you needed to do the camera setup, would set it up in the hardware screen, and like you'd set it up under the gimbal screen. And so the most common thing in here is, depending if you have it on a gimbal or have it hard mounted to the bottom, probably the most important thing in here is this shutter option down here. So this shutter option controls how you would be triggered to actually take a photo. I would suggest visiting the ArduPilot documentation for further information on how your specific setup. So whether it be a servo controlling it, whether it be a relay or transistor, there is quite a few. So as an example, if I pick, say, servo 9, we've got the servo limits min and max, and basically when it's pushed, when it's not pushed, and how long it should push it. These are all just options which really depend on your setup and your drone. So at this point in time, I'll just switch that back, just because for a test it doesn't actually matter. But if you were doing this in real life, that would matter a lot. And obviously if you had a gimbal as well, you could like a pitch and roll stabilized gimbal as well. So that's pretty much it for that part. So a drone is currently landed. It's pretty much ready to arm and take off. The camera gimbal is set up. So what we'll do is now plan a mission. So Mission Planner supports actually 4 different types of grid generation. So the main one, standard grid, corridor, spiral, and one from someone else from a different company, base map. So the grid, corridor, and spiral are all for top-down approaches. So their typical uses are, so for a grid would normally be photography of an area, say this entire property here. You could do the grid over that. Corridor, if you wanted to do a road, so you would fly the entire road to do survey, to do a river, a road, a power line, a pipeline, that type of thing. And the last one is spiral. And what spiral is for is, spiral is more for a lawn mowing pattern. So if you were to, it would fly around trying to carry it inside the polygon. So I will show each one of these. They all have their different purpose. And the very last one, which is slightly different, face map. So if you had a cliff face and you wanted to take photos of that cliff face, this is where you would use face map. So we'll go through and we'll see how it looks. So the first thing I'm going to do here is I need to draw a polygon. So we've already connected tool, as I said before, gimbal's all set up, camera's all set up. So what we're going to do is I'll click this button over here and we'll draw a polygon. So what I'm going to do is, at the moment, say I want to do this property, so I'm going to click this fence here, I'm going to click it over here and here, here and here. So we've got a polygon. So let's go. So I'll right click here, go to auto waypoint and go to survey grid v2. Oops, sorry, survey grid if I want. So that loads this interface here. So this interface is designed mainly to take photos, aerial photography. So I'll just make this full screen so it's nice and big and zoom in a little. So the first thing you would normally do in this screen is camera. So in this case, I'm just going to pick a 6000. No real reason for that other than it's easy. So the altitude is what height the quad is going to fly at to take these photos. So probably the biggest thing with it controls how often you need to take photos. If I decrease the height, you can see that it gets a lot more. I'll just turn internals off for a second. And if I decrease, see that I can do it in a lot less. Now, what you'll also notice if you look down here on the bottom, you'll see the field ground resolution, 20 centimeters. So as I go higher, you'll see it get worse. Oh, sorry, not 80 centimeters, 0.8 of a centimeter. So we're at 2.16 centimeters now at 111 meters. And if I go all the way down, say at 30 meters in a quad, so we'll get 0.6 centimeter ground resolution. So each pixel on the camera would actually be 0.6 of a centimeter resolution. So a couple of the other stats here are the total area would cover, so 3,400 square meters. Total distance is half a kilometer. Distance between images is 7 meters. So the reason why these numbers are important is not all cameras can take photos continuously, there is a limit to how quickly they can write to the SD card and other things like that. So probably the biggest number to look here is the photo every estimate. Currently it's at 1.45 seconds. So what this is saying is if you were, and if I look over here, the flying speed at the moment is at 5 meters per second. If you were flying at 5 meters per second, it would be taking a photo every 1.45 seconds. So if I decrease that time, you'll see that the photo every goes up. So if I fly at 2 meters a second, it's going to take a photo every 6 seconds. So it's important to control this to control how quickly you can take photos. Most cameras take photo maybe in 1 second or less than 1 second, but because obviously we're going to be taking 43 photos in this situation at 3.6 seconds apart, we need to make sure that the camera is actually capable of doing that. So one of the other important fields here is the minimum shutter speed. So I'm going to increase the speed back to 5 meters per second, and you'll notice that the minimum shutter speed is now 1,666. So it's important. So this is a recommendation on the minimum shutter speed you should have. Obviously faster than that is perfectly fine. And what this field is based on your flying speed will actually determine how much motion blur the photo will actually have. So if you try to actually shutter speed faster than the number quoted here, that will basically decrease the chance of motion blur. Anything below this number and you start into pixel motion blur, which of course means a worse final result in the orthophoto or the digital elevation model. One of the other things here, ground elevation, 36 to 42 meters. So what this is saying is that there is 6 meters of height difference between, say, one end to the other end. It's actually an average, so it's just telling you. So as an example, if I change my altitude to 5 meters, that would be a bad option here, because if I were to take off a 36 meter end, I've only got 5, and I'm only flying 5 meters above the lowest point, then I could get very close to the ground at depending on where I took off. So it's just a rough guide as to where and how you should be flying. Distance between lines and footprint, number of strips. Number of strips is just the number of lines back and forward. Number of photos, so pictures, 44 photos would be taken to cover this area. So to give you a visual illustration of the photos it would be taking, you can turn on internals over here. It will show you where it will try and take a photo of. So basically those 44 photos are these points here. When using it, it's not as exact as this because we use DoCam trigger dist. So basically it will use this distance between photos to basically take, yes. So yeah, distance between lines is 10 meters, and currently we're 10.58. Photos are every 10.58 meters as well. Okay, so if I go higher, you can see that the photos get less. If I go lower, the photos get less as well. So sometimes another factor that you may want to do is if there was a lot of wind, you change the direction of the grid. Say if the wind was coming from the top of the screen here, what we might want to do is, instead of having to fight the wind, we might want to fly crosswind. So instead of flying it north to south, we could actually fly east to west. There's a few different options depending on where you wanted to actually fly it, and if the wind is playing any part of it. So yeah, and so we've already had a look at the speed here, so that's fine as well. This next option, add takeoff and land waypoints, can take off and land at will and use RTL RTL is an RTL at the end of the mission. So normally in ArduCopter, the copter will stop at the last point and just loiter at the last point. So they use RTLs to make sure that it comes home and tries to RTL. So I'll just turn off internals again. So we'll turn off, and I'm going to turn on footprints. So this will give us here of where all the photos will be taken and their number of overlaps. So as you can see over here, so we've got a blue dot over here, which what's that? There's going to be 2 photos covering that where that blue dot is. So the cyan dot is 3 photos. This purple dot down the bottom is only 1 photo. So, and the red dots in the center are 7 and 8 photos. So as you can see, we're getting a lot of coverage in the center square, but towards the maybe we're not actually getting enough photo coverage to actually do what we want to do. So one thing you can do is I'll just turn off the markers again, and you can actually drag the polygon points. So if I go over this the side edge of the polygon, and I can actually drag this point further out. So because I want a better coverage, I'm going to out here, and what I'm going to do is I'm going to do that on every side, just so that I get some nice red dots right into the center as well. So but for photogrammetry, obviously you want a lot of overlap on the area you actually want. So I'm just going to drag this, and maybe I'll move that one over there a bit more as well. So maybe, there we go. So now that we've got a lot more photos over the area I actually want, oh, maybe I'll just improve this up as well. So what I'm going to do is I'm just going to adjust the angle to better optimize for what we have here. Just so I can, so obviously the angle that you use things as well as to how the lines are currently fit inside the grid. So I'm probably just going to pick there. So here we're getting 6 plus photos of this area. So, and we're getting 4 in that corner. So maybe I'll push that out a bit more coverage over this area. So there's looking a lot better. So right up to the edge of the property line, I'm getting 6 photos over this other side, and the front and back are getting plenty of coverage as well. So that's how you can use the footprints. The footprints are actually based on the camera you pick from the menu. So always make sure you pick the right camera, and obviously it's been configured with the right lens as well. So I'll just turn footprints off and turn markers back on so we can see what our grid current. So that's looking okay. So now we'll go to the grid options. So the grid options, so what this controls is for a copter it doesn't matter as much, but for a plane you might need to, because the plane can't turn around on the spot like a quadcopter can, you may need to use overshoot and undershoot. So 2 values for undershoot and 1 value for lead in. These numbers actually control how far outside the grid it will fly before it comes back. So if we overshoot and we change this to say 20 meters, you'll notice the points jump. So we've just flown up this line here. We've got, and we've basically flying an overshoot to 0.8, and then we're turning around to come back to 9, 10, and flying back the next line. So that's currently set at 20 meters. Change it to just 5 meters, which will pull it right back in. And then the overshoot, other overshoot is the other shoot at the other end. So if I change this to 20 meters, you'll notice that it jumps out at the other end. If I change this one as well, now they're both 20 meters. So again, this is primarily used if you were flying in wind, or if you had some other reason to do so. 0 is a valid value as well for this, so you can leave it at 0 if you wanted to. Now, so I've set both the overshoots to 0, and now you can see that in is currently set to 3 meters, and the lead in, you can see how it's actually put a point outside the line. So even in copter, sometimes this can help, because what it allows it to do is the copter to be pointing the correct direction before it gets to the side of the grid. it matters a lot more, because quite often after turning with a plane, it might still be banking. So you can control, based on your plane's dynamics, you can control the leader needs to be away for the plane to get back online given your airframe. So yeah, so we can set it at 0 or we can set it at something higher. So what I'll do just for this is I'm going to just stick 5 meters for them all, just so it's nice and easy, just so we've got a little bit of overshoot so we can come back in online and it does everything better too. So now the next thing is start from home. So at the moment, if you have a look at waypoint 1 is down the bottom right hand corner of the screen. So what I'll do is I'm going to change the start from to say bottom left, and now you'll notice that the number 1 is over in the bottom left, top left, again left, bottom right is the same as home, because so with home, depending on where you set your home, it will automatically pick the closest point to home. So in bottom right and home actually did the same thing. Top right is top right, and point currently doesn't actually really do anything. So currently point bottom left, but that's just happens to be a coincidence. So now the next valid numbers are overlap and side lap. So overlap and side lap actually control how much the lines, when you're taking a photo, how much overlap you get between the photos as you're flying up the line, and how much side lap you get is between lines. So if, as an example, if I turn on footprints again and I change the overlap to 0, you'll notice that I get so if you actually look on the lines, you'll notice that I'm getting very few shots on the actual thing. I'm actually getting, but the reason I'm getting more than 1 at the moment is because I actually have side lap. If I set them both to 0, I only get 6 photos. So obviously 6 photos would, to make this work, because there's nowhere near enough. So if I change the overlap to say 10%, you'll see, you can see the sketch of the outline. You can see that there's a little bit of overlap there, a little bit of overlap there. So normally, and the trick, that one thing you'll notice here as well is that you actually don't get overlap here. Now the reason for this is because the ground actually goes up. So this comes back to that ground elevation thing I was talking about before. So just from looking at this, I can tell down here is 36 meters down the bottom, and towards the top it must get higher, and that must be close to where the 42 meters is, because we're getting closer to the ground. The actual the amount of ground the camera lens sees is actually less. So what we were doing, this is the reason for using 70% overlap. So 70% overlap, so you can see now that we're getting a lot better coverage. We're still only getting 1 photo right at the very top of the grid, but so far I don't have any side lap. As we add side lap back in as well, you'll see that it goes back to its nice, fairly dense point cloud number of photos to cover the entire area. So that's all the main settings. You'll notice that I skipped over distance between lines. So if you pick a camera, you can't actually change this because this number is automatically calculated. If you didn't pick a camera, so if I were to get rid of that, you can actually change this number if you wanted to manually control it for some reason. But in this scenario, I'm going to go back to just using the camera profile. 3 options are 3 tick boxes. So this is what I was talking about before with the different types of grid. So this is what you get is a normal grid that we the next one is, so this is an option to enable, is a cross grid. So what it does is it will fly north to south, like in my sample here. Turn on cross grid, it will actually fly north to south and east to west. So I'm just going to quickly go back and turn off footprints to get rid of that, so you can see that more clearly. So as I turn it on, so as you can tell, if by flying across grid over a small area, you make sure you get a lot of coverage. Where this is if you needed to get the side profile of buildings. So flying north to south, so if, as an example, if I fly north to south, I'll get a very good shot of, say, this wall here. The wall will only be oblique angled from this line, and this line. So that'll be 3 shots of this flat. Whereas if I do it this way, I will get additional shots of that flat wall as well. So what it allows is a lot more points to allow a better reconstruction using photogrammetry software. So if I turn on footprint again, you'll notice that when I turn on grid, so obviously I don't have super good coverage on the outside. I've got pretty good coverage. I'm getting maybe 6 photos on the outer edges, but when I turn, that jumps to 8+. So I couldn't tell you how many I am getting, but it's going to be more than 8. Currently, Mission Planner only shows a maximum of 8, but I'm pretty sure a lot more than 8. So that is cross-grid. So what I'm going to do is I'll turn off footprint. So I haven't made a very good example. So this is a quick look at corridor. It doesn't look very good at the moment. So what I'll do is I'm just going to jump out and make a better polygon that is for a corridor. So under the polygon, so I click that over here, clear the polygon, and I'm just going to zoom out. So what I'm going to do is click it, draw a polygon. So I'm going to go there, there. So corridor is really for sort of road or something similar to a road, river, power line, whatever you wanted. So there's currently a bug in Mission Planner where it draws this extra line here. That's because obviously I don't know that you're going to be drawing a corridor just yet. Where I still think you may be getting a polygon or a survey grid. So what we'll do is we'll just go straight to survey grid. So currently that's opened here. There is a lot of points. So I'm going to turn that into a corridor. Okay, so what this does is it will fly down the line and then turn around and fly back down the line next to it. So currently our corridor width is set to 100 meters. So let's change that corridor width. It's using the same stuff as before, so we're still using the same camera, we're still using all of that, and the distance between lines is still 10 meters. So using that maths, I can say our center line plus 10 meters, so let's make this 11 meters, and I should get 1 line either side. Oh, maybe not. I need to double it, so let's go 22 meters. There we go. So what that'll do is that'll fly that line and get the corridor width of 22 meters. So yeah, as I increase this number, it will fly more and more lines to try and get your corridor width. So depending on the width of the rule or whatever it is you needed to do, and this is obviously using 10 meters there as well. So it's really, so currently we're flying quite a wide line there. For a road, you probably would never have to actually fly that wide. Like, so if I reduce the altitude, you can see that it gets more lines. And at that point, maybe we're only fly 30, a total corridor width of 30 meters. So that's probably more realistic there. You get the road, the shoulder of the road, and just into the start of the people's properties. So for doing road surveys or road ASCONs or that other type of thing. So with this, again, if you needed to move a point, you can do that as well. So I'll just turn off markers, I'll zoom in. I don't like this point, so what I'm going to do, I'm going to move it. So as you can see, I can move the point wherever I want to move it. So that looks more online there. So I can do this with all of the points as well. So if I didn't move them in the right spot to start with, which as you saw, I did it quite quick, but I'm happy with the result. So so that is an example of a corridor. So our next one is spiral. So what I'll do is I'm just going to moving ahead with the spiral as it is. It's probably not really ideal, but we'll do it anyway because it's such a large area we're going to do a spiral over. So this is a spiral. So we start from, where are we? We're starting from home at the moment, so we're going to be starting probably from over here somewhere. There's waypoint 2, so we're starting from right there, which our home is, so that makes sense. So this is a spiral. So the most common use of this is for rovers, for something like a lawnmower or for spraying, some other purpose. Obviously this can be used with a plane or a quadcopter, but the original intent was for a rover driving along the entire area. So again, 3 meters, 3.8 meters between lines here, and it just drives around doing different types. Like everything you saw before, you can drag the markers around the edge if you want to, and it will dynamically create stuff. It's not, I will say it's not 100% perfect. Like you can see a bit of an error going on here, but that really depends on the tool you're using. So for simple polygons, non-self-intersecting polygons, obviously it works pretty well. If you make them a lot more complicated, then things get a lot more difficult. So that of a spiral. So that's pretty much all of those. So I'll turn off spiral and we'll go back to just a normal grid. My altitude up a bit so we're not flying so many points. Okay, so the next options are the Copter-specific options, is delay at waypoint. What you can do here is, if I set this to 1, what this will do is when it flies to the end of the line, it'll stop for 1 second and then continue on to the next line. Where this helps is when you want more control, and sometimes ArduCopters will not take a photo, may not take photos towards the end of the line, and the quickest, this is actually a bug in ArduPilot, but I think it's actually fixed now, but in older versions you'll come across this problem where it the corner at the end of a line, and the best way to get around this is either to add a delay or to set the lead out maybe longer, so when it cuts the corner it's in the lead out area anyway. So there's a couple of ways to get around that, and that's the 2 ways that I'm aware of. Heading hold. So what heading hold does is, say you're in a copter and you want it to face north the entire time, but you want it to fly this pattern here. So you're on a 45 degree, but you want it to be pointing north the entire time. So using that, I can just decrease the numbers here, and it will actually fly in the opposite direction, which does not appear to be working for me at the moment. Getting hold of the opposite direction, so backwards flying the line or forwards flying the line. Okay, so unlock from grid, there we go, 0. So if I unlock it from the grid, so now I can make it point north the entire flight, even though it may be flying, it'll be forward and to the right over here, and then it'll be flying backwards to the left on the return line. So it's one way of making sure that the camera, if you had a requirement for the camera to be facing a specific way or some other thing, if you were flying a different type of sensor, whether say it was something, a magnetic sensor of some description, and it needed to be always pointing north, so you can make the copter fly any direction you want and keep the copter itself always pointing north, but it'll just lean a different way to move in that direction. So I'll just turn that off for a second. And so the last option in the copter options is spline entry and exit. So what this does is it'll actually spline on the lead in and lead out. Lead in and lead out, yes. So what this does is it makes a nice smooth path. So as you can see, it's got square corners. putting a spline there will mean that it won't really have a square corner. So it will actually fly out and then fly out. Current survey grid doesn't show this, but it will actually do that quite fine. So, so what I'll do is I'm going to leave spline entry and exit. And the last one is a plane option, which actually works on Copter as well. So if for some reason, if you wanted to come out this line here and then instead of flying down the line or to fly down this line over here instead, you can change this number here. So it actually changes basically it's a skipper line. So as you can see, this one flies up here and then line to this line and then flies back. If I change that to 2, it'll skip 2 lines, 3 lines, and so on. So normally for planes, you would use, because a plane can't turn around in that distance. So in this example, it's 14 meters. A plane cannot turn around in that distance. So by changing the minimum lane separation to 1, the plane's going to have, what, close to 30 meters to turn around, bank around and get back online. Obviously, if I change that to 2, then it's going to have even more. So we skipped 1 line, 2 lines, and we fly down the 3rd line. So that's a very good option for plane. It does work on Copter as well, but for Copter, it's not really necessary good spot. So, and the last option is camera config. So what you'll see here is, so in my camera, the Sony A7, I've set up for a 20mm focal length lens, and the photos that takes are 6000 by 4000 pixels, and the sensor width as well. So what this is using the numbers is calculating a centimeters per pixel based on the current altitude, and that gives the vertical field of view, which you actually notice that these numbers are down here on the bottom, and they are the same numbers as the footprint. So those numbers there. So if let's just to say the next 16mm, and I go back to here, you'll see that these numbers have changed. Our centimeters per pixel now go to the 1.3 centimeters per pixel. But our vertical and horizontal field of view go to 60 by 40 meters. So a much larger field of view, and that's based on the focal length of the lens on the camera. So next 525mm, again, same image width, same sensor width, different focal length, and now we've gone to 38.4 by 25 for the footprints. So if I turn footprints on, you can see there's a lot of photos. So there's 876 photos here, and we've got the footprint coverage there. So by the look of it, a lot of these footprints are getting about 4 overlapping photos. Down the bottom, we're getting a lot more, and the reason for this is we're going from to 56 meters in this example. So there is, what, 15 meters of difference between the bottom of this hill and the top of this hill up here. So the reason for that variance there. If I were to turn on cross grid, obviously we get very good coverage, just like we saw before. Very good coverage when we turn on cross grid, and you get of all the buildings, all the houses, and all the other things. With photogrammetry, obviously the more photos you can get from more different angles, the better. Different oblique profiles of certain objects, whether it be a tree, a house, a building, a tower, any of that stuff. So I'm just going to footprints again, and yeah, so that is pretty much a guide to. Oh, one thing I missed is the trigger method. Method is how ArduPilot is triggering the camera. So at the moment, the default method is cam trigger distance, which what that means is when it enters the grid, it's a number, the cam trigger distance, which is our 11 meters at the moment. Oh, it's 7 meters, sorry. 7 meters between images. So 7 meters, cam trigger distance is automatically going to trigger the camera. So which means a photo every 1.5 seconds and with a recommended shutter speed. Our total flight time for this mission, 33 minutes. So yeah, that's that. You can do digicam control. That is actually not really more. If you're using a very old version of ArduPilot, you would use that. Do repeat servo. So if you wanted to manually control the servo for some reason, the cost of using this option here is it creates a lot more waypoints, and you might hit that ArduPilot waypoint limit by using this method, whereas the distance will be a lot more efficient and a lot less waypoints. And do set servo is again the same, controls the servo going high and low based on being in and out of the grid. So that's pretty much everything here. That's everything to do with the survey grid. So one more thing is we'll have a quick look at face map, and I'll quickly come back to that afterwards to give you a rough idea on how you would actually program the mission and actually fly out. So what we'll do is, let's pretend we wanted to fly the front of this house here. So what I'm going to do is I'm going to draw a polygon. Let's fly from here to face map. I'm just going to pretend that there's a cliff right here. So there's a sort of a cliff at the front of this house here, and let's pretend there's one over here as well. So we've got the points. What we're going to do, map tools, and go auto waypoint, sorry, and go to face map. So that will give you a screen like this. So our original line, and you can see what it's doing here. So at the moment, what that's doing is that's actually flying from that line, and it would actually be flying. So this line here is actually this bottom row here. So let's change some of the numbers here. So again, Sony, let's use the next 5 16mm. I'm going to direction, so I'm going to fly up the hill instead of down the hill. So I actually get a map of the entire thing. There's a few different to adjust in here. So let's go to bench height. So the bench height, so this is all illustrated. As you adjust the numbers, you can see a rough representation of what you're going to get. And then is what kind of angle it's on. Say you wanted to fly a sloped hill or something similar. So let's go back to 90 for that. And then the actual depth of the hill. So say it was a very flat surface. We can fly a slow slope, or we can fly something, say 5 meters in each step. So it goes up in 5 meters, up in 5 meters, up. A number of benches, so we can add how many times we do that. So we go up 1 meter, and of course, if you wanted to purely just not have any steps in like that, just decrease the number of benches, and then increase total bench height. So say we're at 24 meters at the moment, say I wanted to go to 50 meters high in a straight line, then that's what you would do. You can also control your cameras maybe at a funny angle. You can actually determine, type in here, so say it's at 45 degrees for whatever reason, you can factor this in here so you can get the right amount of coverage. So I'm going to change that back to 0 degrees. Unlock camera pitch, so that's just the ability to change that number there. And then this one here won't actually do anything, because so this is like the start takeoff height. So how far off the ground or how far above the start point you will begin with. Again, add takeoff, the start, and the end as well. So, and the next trick in here is the follow south home. So say obviously you don't want it to cut a corner to fly back to the next line. So what this does is it controls the path that takes to the next line. So it travels along the already traveled path that has been planned, so it doesn't try and fly up and across, and possibly there'd be a tree in the way, whatever other factors are there as well. So just like the previous screen, you've got all the grid options, the flying speed, the distance from the face, so 20 meters say, side lap and overlap, you can change these again as well, how dense you want it, delay at waypoint just like you saw before, capture corner images, and yeah, so it's really just like the other screen, but purely for vertical face. And yeah, so that's a quick example of the face map. So now that I've showed you all of those, what I'm going to do is I'm going to quickly we're going to just draw this box around here again. We'll do it the quick way this time. So quick survey grid. That's me, 31 meters, A600, 5 meters. So flight time is 4 minutes apparently. So footprints are good as well. Let's turn off markers so we can sprint. Oh, turn off internals. So it looks good to me. So what I'm going to do is I got spline entries and exits turned off, on, and accept that. So we've just accepted the mission here. It's brought it into the main flight planning screen. If you needed to add any extra points, now you can do it. So our first waypoint at the moment is 20 meters, 30 meters high. Delay that doesn't actually do anything. We change our speed to 5 meters per second, and then we got spline waypoints into our first point with a set cam trigger distance to 7 meters. So what I'm going to do is I'm going to quickly look this to the drone. So that's written now. So as I said before, we've been connected to this drone the entire time. We've uploaded. So what I'm going to do now is we've got all our stats. We're going to arm it. It's now armed, and right click and take off. I'm going to take off to 10 minutes. Now we did, because in a normal situation you would have a transmitter, so you could flick straight into auto and raise the throttle. Because I don't actually have a transmitter, this is all in the simulation, I just switch armed it and use the right click takeoff command. So we're now in the air at 10 meters, and I'm just click this into auto, and it's going to start flying the mission. So it's going to fly to, what is it, 31 meters, and then continue on meters, and then it's going to start the mission and start taking photos. So Mission Planner has the ability, if you have a good telemetry link, to show you the taken. So as you saw there, there was it was a bit of an early photo, but we've taken a photo already, and as it flies this line, it's just going to keep taking. And there's a stencil on the ground of where it's the photo, the camera lens was pointing at the time. So as you see here, we're flying that photo, and everything should be good. We made it to the end. We've got a photo near the end. It's actually slowing down and stopping, and then it's going to continue on. So like before, when you saw how we had the camera overlap, you can actually do the camera overlap in this screen as well. It's not turned on by default because it actually uses quite a few CPU resource to do that, but I'll turn it on now for this demonstration. And as you can see, so as it flies along, exact same color scheme as before, you can see how the colors are in when you get lots of overlap. So we've obviously got a fair bit of overlap here. We're getting some nice reds. And then out on the edges, we're only getting 1 or 2 photos. So this is a good way to illustrate live. And obviously, you've got to have a good telemetry link here for it to work properly. If you're simulating it, we have a perfect telemetry link, so everything works exactly as you'd expect it to. You can mouse over it. You can have a look at the photo. So we're at 7/8 of degrees roll. We're at 68 meters high when that photo was taken, and yeah, and you can basically mouse over any of them and it'll show you the footprint and the roll and the roll as it was taken and the photo number as it was taken as well. So that's pretty how you would fly create a very simple grid mission and fly it. So one of the other couple of things that we're going to do is, so say you've just done this mission, I'm just going to make this thing RTL, split the mission halfway through. So that's going to basically go land now. So assuming you just got all these photos, so I've disconnected. I'm gonna basically download the data flash log. So you download the data flash log. Oh, I can't do it now because I'm in the air. So what I'll do is, so I've actually have a demo here where I can show how you'd use the georeference function in Mission Planner. So what I'm going to disconnect from the simulator, and what we'll do is, so we'll go in the data flash log tab, we've got a georeference image option. So I'm going to open that, and that will load a screen that looks like this. So we've flown our mission, we've got our photos off the camera, we've got our data flash log and our T-log. What we'll do is we'll browse for this T-log. So here's one I've prepared earlier. It's actually from back in February this year. So this is the data flash log. I'm just going to open the data flash log. The actual photos are in this directory as well. So I've put all the photos in this directory. So we've got what, 50, 60 photos and the data flash log that goes with it. So I'm going to open the data flash log, and by default Mission Planner expects the images to be in the data directory. You can browse for pictures and point it to a different direction, but it's automatically looks for it in that directory. So because I know my camera was I'm going to use cam messages. And so what this screen does is it reads the log and will try and read all the information from the photos to try and correlate them and to try and tag those photos. So I'm going to click pre-process here, and what that's going to do is going to process all the logs and show us where each photo is, so the path the drone took and the photos on the map. So so say this one here. So this one here looks like it was close to the road, so I'm going to click it. And sure enough, looks like it's pretty accurate to me. So this one should be on the far side of the road. Again, it is. This one on the other side of the road, it looks good. So this is just to everything is doing what it's meant to be doing. So let's go down here. So let's look. So we're in the middle of this big white sand paddock. So I'm going to click that. That looked accurate to me. So it looks like the alignment's done properly. So this is using the cam message method. There are time offset and triage method ways of doing this as well. Cam message is the best way because it gives a one-to-one relationship between the number of photos you took and the number of messages in the ArduPilot log. So if there was any problems in recent Mission Planner versions, that you have the ability to drop images at the start or at the end. Say you had 5 photos you had to delete from the start, you could counteract that here for whatever reason. In this situation, location KML, if you had Google Earth, you can actually load what you see here in Google Earth just to compare that the photos are lined up, but I'm actually pretty happy with that, so I can actually skip this location KML and just go straight to geotag images. So I would click that. I'm not going to click that because I already have them geotagged, but if you were to click that, it will go and add these locations to the actual images and create it in a new spot. So if I open this directory that we just it created a geotagged folder. I open that, and all of these photos in here are geotagged. So if I look at the properties on the photo, go to details. And down here, we've got a latitude, a longitude, and an altitude that the photo was taken at. So using this, you can load this photo like PhotoScan or some other photogrammetry software, and it will automatically pull the lat, long, and altitude from them. If you had wanted to get it into a different program, when you click the pre-process location button, Mission also creates all these files here. So these are different formats, all containing the same information, but for different software. So if we open location.txt, you can see an example here of, so that's the file name, the latitude, the longitude, the altitude, the roll pitch, and the yaw, and the sonar altitude that it was taken. So that would be that photo there, is that there. So depending on the software you're using, you can actually import into different software that maybe can't read the geotags or something else. Or if you didn't want to geotag the photos at all, you could actually just use your for the camera and this file, and you can import everything you needed to. So that would be, I'll just basically that there. So what this does is, let me just quickly, I'll quickly open PhotoScan. So this is the actual, this was processed in low quality very quickly just for this demonstration. So there was 71 photos, all aligned, and there's all at the end there's an ortho mosaic. So we can see the ortho mosaic, we can see the photo. So now that we have a nice georeferenced orthomosaic image, and so I've already saved this. So this is the processed inside PhotoScan, or Metashape Pro, sorry, used to be called PhotoScan, and nice grid here. So I've saved these already. So here is the so I've exported them from PhotoScan into a format called GeoTIFF. So GeoTIFF has the ability to save the lat long of the entire image. So the reason for saving this is I can now load this into Mission Planner to plan against. I've also saved the DEM from it, so the digital elevation model. So this is basically just a height one. So this is, and this is for height. So I'll just close PhotoScan and I'll just quickly open Global Mapper. So using Global Mapper, I can, so let's look at the DEM. If my computer doesn't seem to like that at the moment. So this takes a little while to load, but this is the digital elevation processing. So the reason I'm telling you about the visual and the DEM, so this is the DEM of that photo data. So you can see there's high points. If you look down in the bottom left-hand corner here, you can see the height. So that's 9.17 meters. And over here, we're at 7 meters. Ground level there is about 5 meters. So you can see the area here where the DEM. So you can actually load this DEM, which is saved into the GeoTIFF format, to Mission Planner and use it for planning against. So if you had a site where you needed to go back multiple times, you can actually use your orthomosaic, your image, DEM that you've generated from your previous things, and load it straight into Mission Planner. So what we're going to do is, I'm just going to open this folder. So I put this for a reason. So I'm just going to copy and paste this path here. And what we're going to do is we're going to open Mission Planner. So there's my previous path, and I'm just going to close out of this because we've with that. I'm going to go back to here. I'm going to clear my tracks just to clear the screen, just to get rid of some of that stuff. And what we're going to do now, so to use some of these options, they're currently not available in the normal user interface to Mission Planner. So you've got to use the option. There's two. You can go to Config and go to Planner, and right down the bottom there's the testing screen. Or the other option is to press Control F. Will load this screen here. So in here, there's two buttons that I'm going to show you. There's this DEM button, which stands for Digital Elevation Model. And then there's one called Custom GDAL, which load custom map source from GDAL. So what we're going to do is we're going to load the aerial photo using Custom GDAL. So I'm going to quickly browse to it, demo, and the path that I had before. I'm going to accept that. So that's loaded already. And while I'm also here, I'm going to click DEM. So that will load this screen here. And DEM is a little bit different. It's a lot less integrated. So I'm going to copy my farm.dem. Going to copy that into the open DEM directory. So I'm just going to paste it into here. That's now copied. So that DEM is 390 megabytes. So it's actually quite a large file. So I'm just going to close that, So now that I've done that, I'm going to have to restart Mission Planner to let them load properly. So I'm just going to close Mission Planner and then load it back up again. So because I know where those points actually are, I'm going to zoom out and where those photos were actually taken. Okay, so as you see at the moment, it's the original photo, just a Google Earth photo. And if you actually look, you've got our lat, long, and altitude. So our altitude is currently SRTM. So as I move my mouse around, you can see it's SRTM. But if it's loaded already, which I move over here, you can now see that it says GeoTIFF. So when we did move that GeoTIFF into that DEM directory, it actually loads it to DEM. So as I move my mouse out across the edge, it switches back to SRTM and back to GeoTIFF as I move it around. So as I actually look here, depending on how accurate it is, jump from 7 meters just there down to 5 meters just there, which is actually pretty accurate. So SRTM data, as it comes, is only 90. There's only 190 meters, so its accuracy is not very good. Because I've loaded that DEM now, you can see it jump from 7 to 5 meters as it's falling off the side of that building there. So that's the first step. We can confirm that the DEM is working. So the next thing we're going to do is we're going to go to change our map source to GDAL custom. As we did before, we set the custom GDAL image, so I'm going to change to that. Oh, and I've zoomed back to home automatically, so I'm going to go back to over to here. There's our imagery loaded into Mission Planner. I'm just going to set my home here as well so we don't jump away again. And so now we've got our custom GeoTIFF for, also got our custom photo for the map. So if I zoom right in here, might take a little while to load because I haven't these tiles. So as I move it from here to here, so we jump from 7 to 5 meters. Now it looks like there might actually be a little bit of an alignment issue here, but it might actually be the fact that the way this photo has been taken, that's on a lean. So the actual corner of the building is back here. So according to me, the corner of the building is about there. So at ground level, it must be about there. Jumps from 5 to 7 meters. So another way to visualize this is there's another keyboard shortcut for Control W. And using Control W, we can turn on terrain. So using terrain, we can visualize that height data. I zoom right out, as you can see. So all of these heights around here are based on SRTM data. But as we get into where I loaded the DEM, you can see that height difference. So like out the front of the property, you can see the trees out the front of the property. So we can see that the trees here are 9, and then down on the ground here we're at about 3.9 meters. So there's the DEM is doing its job. You can see that the building DEM, you can see the nice edge of the buildings there against the DEM. Oh, there's obviously a very big tree just there, and you can see where all the and other things like that. So it's a good way of checking the DEM is loaded, and it actually looks pretty accurate, which to me it does. Like in a little bit of a shift in the DEM there versus the ortho photo. I did process this data in low quality though, so it's not too big, but it's not the best quality. So what I'm going to do is I'm just going to Control W again and turn terrain off, and we're back to the normal with our custom imagery loaded. So that gives a fairly big overview how Mission Planner can be used and how the data you capture can be put back into Mission Planner to make planning better in the future. This situation, the Google Earth data looks pretty good from the image we actually captured. You can see the paddocks, you can see the buildings, and you can see the way they actually join up to the Google Earth data quite well, which can be used for planning high quality things like this. This is a class example of where I showed you the spiral pattern lawnmower to mow this front area here. It would be a perfect candidate for that after. So fly it with a quadcopter or a drone to start with to get a high quality map, and put it on a rover to actually lawn mow this area or something similar to that. So that pretty much covers the stuff that you would need to do a nice aerial mission. So I suppose is the questions now. So that's the basic rundown of how to do that. Are there any questions from anyone?
Yeah. I think it's Mr. Michael.
No questions at this point?
Yeah.
Yep.
This was really interesting. You told us
Yeah.
everything. When we first started Mission Planners, we took around 10 days
Yeah.
to figure out to use it and everything, connecting it with Pixar. That was a really challenging task.
Yeah. Yeah. So yeah, there's a lot of other features in Mission Planner as well, which obviously I haven't touched on. But that for the mission planning and survey missions and mapping missions. So what I showed you is a good case example of a mapping mission. This map is actually done with a 3DR Solo back in February. I just have the data for it, and it's convenient to use as an example because I have everything I need to show exactly use it and how to use it for both elevation data and also for aerial photography. So it does a lot of stuff, and using and everything else. There's definitely a lot of possibilities. It's really about using it to the best of your advantage and knowing how to use the tools to make use of your advantage. So yeah, it's good.
Yeah, this was quite informative and educative too.
Yes.
To the webinar.
Yeah.
This was really interesting.
Yeah.
So analysis of Mission Planner for cargo delivery.
What was that? Sorry.
Like, what are the challenges of Mission Planner for using it in cargo delivery using drones?
Some of the challenges. I don't think there are any very big challenges. It's really a case of how you want to use it. So, like, there's a few things like they're not really mapping related stuffs. Mapping, there's obviously some pretty good workflows for mapping at the moment with different GPSs and some different there's a lot of technology put into around surveying and mapping. The new emerging stuff is around swarming and other things like that. So swarming is definitely a place that's getting more interesting, and also a lot of live video feeds for cinematography and things like that, where there's a lot of unseen complexities. Like photography, obviously you've got cameras moving in a specific way. You want it very, very smooth and non-jerky. So it's a different kind of environment to survey and mapping. So, but yeah, there's definitely a lot of challenges. And yeah, so other challenges are things like going platform, like going to Android and things like this as well. So like I'll just quickly demo this as well, just because it's worked on at the moment. So as you can see, here's an Android, and so this is a copy of Mission Planner running on Android. So this is very early at the moment. It's a bit of an alpha release, but it is Mission Planner running on Android. So if you look at these two pictures compared side to side, you'll notice that they are the same, because they are the same. So Action tab everything you see on the full version. Probably the biggest difference is screen real estate, so it's a lot smaller. So, but everything you see on the big one is available on the little one. So everything I showed you with survey grids, so I'm just going to zoom in here. I'll zoom out a bit. So everything you saw with, I showed you with survey grids a second ago. This is still buggy, I will say that at the moment. So like if I go to auto waypoint, the same as in the full one, I go to survey grid, complains about a file. That's a bug at the moment, but everything you want to do is basically the same. So you can control the footprint, you can control everything you want to do, just as you did with the full version of Mission Planner. There are still quite a few bugs. It's not released to the public yet. But yeah, so there's something not very different.
Yeah. 3 models of a surveying area.
So using, it depends on what you mean by 3D models. Obviously, if you're going to be building a 3D model, Mission Planner, like you could take photos to build a 3D model. Say you wanted to survey a water tower or a building. That's where you'd use the things like the face map and other things like that. It really depends on exactly what you wanted to do, because no matter what you do, Mission Planner is the tool for getting the drone to do what you need it to do. If you wanted to build a model, obviously you'd have to use Metashape Pro or some other 3D package to create that. Currently, Mission Planner can't do display 3D models. It does have a small 3D interface, but it's not really designed for doing exactly that at this. If I just share it quickly again, and do is I'm just going to quickly start the simulator again in a different location. So this is actually probably a good test. So we've got our custom imagery here. We've got the starting up. Once we connect to that, so there is one other feature that I've been testing as well, along with the Android thing, is this is in Control F. And in Control F, there's a thing called 3D map. So I'm not quite sure how good this is going to work via screen sharing. So this is 3D map. So using 3D map, it's actually like a 3D render of the world. So let's wait for the EKF error to go away first. And then I can arm and take off. So it went away, just armed, take off to 10 meters. So we've just taken off. And we can fly around this location here in 3D. Here is, so as you can see here, because we're using a 3D view and the DEM isn't actually being obviously, you saw here we have a centimetre level accurate DEM. The problem with loading that into a 3D view is it uses a lot of CPU, and there's still obviously some bugs with the DEM, this view as well at the moment. So it's very early stages, but it is available. It does, but it really depends on what you want to do with it. But yeah, currently there's no way to show a 3D model in here. So if you wanted to put a building in here or something like that, current way to do that. But it potentially possible in the future. The problem here is this CPU to do this, where you've got static models. It's a little bit easier, but there's a fair bit of CPU usage required to do this. And a lot of people using Mission Planner out in the field, they don't have very high-grade laptops doing it, so it doesn't really, there's no, because the level and quality of the CPU in the device doing it isn't high enough to render 3D scenes in real time with a resolution for the ground. So it's not the best idea really. So yeah, hopefully that answers the question.
Yeah, that answered my question. Thanks for the
Yep.
answering.
Not a problem.
So I think we can end our session today. Again for taking your time in this very quick period.
Pleasure to be here.
Okay, Mr. Michael. Thank you.
Thank you.
We'll close it.